Hello students, welcome to this lesson about functions. While in this lesson, we'll be discussing the parabola and the straight line. And I believe you have something to write with and to write on. So let's go for it. Okay, given f of x is equal to negative x squared plus 4 and g of x is equal to mx plus 2. We have the equations and the corresponding sketches. We have questions based on the sketch and the equations, of course. So we want to understand the meaning of these equations, okay, and translate the information to the sketch. So let's start with f of x. F of x is equal to a negative x squared. If the coefficient of x squared is negative, what type of orientation will the parabola have? I hear concave down. That's correct. And as you can see, it's concave down, and that implies that there is a maximum, local maximum for this graph or this function. Now we have negative x squared plus 4, and when the equation is written in standard format, we can always be able to read off the value of the y-intercept. This 4 is the y-intercept. We can take this number to the sketch and check where the graph cuts what? The y-axis, the y-intercept. So that value there is 4. Great stuff. We are done with f of x for now. Let's go to g of x. G of x is equal to mx plus 2. It's a linear function. It's given in standard format. Again, if it's given in standard format here, we are able to read off the value of the y-intercept. We are told that g of x cuts the y-axis at 2, so we follow it. G of x cuts the y-axis there, the point called D. Okay, so that is 2, all right, and then it continues. Now, we are given m there, and m, what does it represent? That is the gradient of the function g, right? And looking at the orientation of the line, it's an increasing function. So we can definitely predict that when we calculate the value of m, the gradient will be positive. It will have a positive slope because it is increasing as seen from the sketch. All right, great stuff. Now, before we come here, let us see what else we can pick up in the sketch or add so that we can simplify, our thinking and, make some connections as we go along. A, it is a point on the x-axis. So we classify it as a x-intercept. It's where the graph cuts the x-axis. So this is an x-intercept. What is special about the x-intercept? Y-coordinate is 0. Because when here you want the y-coordinate, you go to the y-axis. You get there and you get 0. Again, what is E? It's a point on the x-axis, so it is an x-intercept. What is happening here? The y-coordinate is 0. How do we know? If you are at E, you want the y-coordinate, you must go to the y-axis. And what you have is 0 there. Good. So we understand by now that B and D are y-intercepts, okay? And conversely, being y-intercepts, what is the x-coordinate? X is 0 here, again, x is 0 there, because when you're at D, you want the x-coordinate, you must go to the x-axis. You get 0 there. Go to the x-axis, you are at 0 there. Great. Let's talk about C as our last point. Okay, it is where, the two graphs intersect or cross each other. All right, so it's a point of intersection. And what do we know about the point of intersection? Grade 10s. Okay, at the point of intersection, this point right here, the two functions will have the same x-coordinate and the same y-coordinate. You see, another way of, or another word of the point of intersection is a common point. So what will be common about the point is the fact that it is shared in terms of x-coordinate and the y-coordinate. Okay, so it's a point of intersection, and we can write this. F of x is equal to g of x, meaning that the x coordinates are the same and the y coordinates are the same at that point. Good. That is enough inquiry performed on the sketch in relation to the given equations as well. All right. And lastly, we can talk about the symmetry of the parabola, which is an important property at this level. We understand that at this level, the parabola is symmetrical about the y-axis. Okay, so the x-intercepts, right, are equidistant from the origin of the Cartesian plane. Okay, so from 0 to A and then from 0 to E, the distance is the same because of symmetry of the parabola. Okay, so we'll have to calculate that later on, as you can see in B, coordinates of A and E. Let's start with A. Determine the coordinates of B and D. We've done that already by just understanding standard format of functions. So it will be 0, 4, and D will be 0, 2. Okay. Coordinates of A and E, what are they? They are x-intercepts, and there the y coordinate is 0. Okay, so in other words, we want to solve for x. Okay, and this y here is 0. Okay, I'm going to produce a simple algebraic equation. 0 is equal to negative x squared plus 4. Okay, so what you can do is to factorize, fix the signs and produce difference of 2 squares, or transpose the negative x squared, take square roots both sides. It's up to you how you want to do it. So it's x squared is equal to 4, all right, because the negative x squared, when you transpose it to the left, it will change the sign. Okay, so what happens from here? You take square roots both sides. It's plus or minus square root of 4, and the answer will be plus or minus 2. Remember, the power of 2 indicates that there are 2 possible solutions for x. So it's very important to indicate a possibility of having those 2 solutions by a plus or minus, of which is what you're going to achieve when you factorize as well, if you use that method. Okay, so the coordinates of A, it is to the left of 0, so it must have a negative x coordinate. So we take a negative 2 for that. And E, it is to the right of the origin, it must have a positive x coordinate. So your A is negative 2, 0, and then your E is 2, 0. Okay, great stuff. So we can put it there. That is negative 2, and that is 2. The follow-up question becomes the distance AE. Okay, so from A to E, what is that horizontal distance? Okay, by symmetry, that is 2 units, that is 2 units. 2 plus 2 gives us what? I hear 4 units. Great stuff. So distance AE is 4 units. Okay, so as you can see, the previous answer helped us to answer the next question. All right, that is called the hierarchy of the concepts. All right, one leads to another, and at the end you have completed this puzzle that you are given in terms of mathematical concepts that you have connected to form one beautiful picture. All right, next one, D, value of M. Look at this. There's a prediction or an expectation that we have that M must be positive because this is an increasing function. So how do we calculate the value of M? Clearly, we're going to need to substitute for x and y here and be able to solve for M. So we need a point on G that we have a right to substitute. Do we have a point on G? Yes, we have A, we have D, we have C, but we don't have the coordinates of C. So you can choose from what? D and A. It's up to you. So since we've spoken about A, let's go to D. Let's use D. Well, if you use D, look at this. X equal to 0. You substitute x equal to 0 there. And M times 0 is equal to 0. So M will disappear, and that will not allow you to solve for m. Are you with me? Yes. So as much as D is a point on the graph of G, it is not a point that will allow you to answer the question successfully, because you dissolve what? M. It will disappear. Okay, you want to keep it and solve for it at the end. So you substitute A in such a way that your x is not 0. And here your x is not 0, it's -2. All right, good stuff. So that is the reason why we use A and not D. Okay, so these are the coordinates for A. Your x is -2 and your y is 0. So we have 0 is equal to m times -2 plus 2. Transpose the plus 2 becomes a -2, and you divide both sides by -2 as a coefficient of m, yes, and you get a value of 1. M is equal to +1. It is what we expected. Okay, great stuff. I believe you're with me so far. And the last question is, get the coordinates of C. What did we say about C? It's a point of intersection. The expression of F equated to the expression of G, and that should allow us to safely work out the value of C. So let's go for it. We understand that at C, this is the mathematics that we need to perform. All right. -x² plus 4, that is the expression. Then we take this expression, the value of m is 1, okay, and we write it like this. That is 1 as a coefficient of x, okay. Produced quadratic equation. Collect your stuff to one side. -x² minus x plus 2 is equal to 0. Multiply throughout by negative. Right. And it's a quadratic expression that you can easily factorize this one. Okay. So it is x plus 2 and x minus 1. So x is equal to -2, or x equal to 1. Okay. So looking at the position of C, okay, it is to the right of the origin. So will it have a positive or negative x coordinate? It will have a positive x coordinate. So we accept this one, we reject that one. X cannot be equal to -2. Okay, in this case, this -2 applies to A, of which is also a point of intersection. But in this case, in relation to C, it cannot be equal to that. Okay, so how do we get the y coordinate? We substitute the x coordinate in the expression of f or in the expression of g, since they're equal at that point. So we can use g, since that is a simpler equation. Okay, so in place of x, as you can see, I've put 1. 1 plus 2 is 3. So the coordinates of C are given by this pair, 1 and 3, and that makes sense. Okay, the number between 2 and 4, the midpoint, so to speak, is 3. Okay, and that completes our discussion today. I believe that you've enjoyed it, you've benefited, and I'm going to leave it here. Thank you for tuning in. See you next time. Sharp, sharp.